My name is Dr. Venu. I am working as a professor in the Department of Civil Engineering in Institute of Aeronautical Engineering, Hyderabad. So today I am going to cover design of steel structures and drawing as a subject. So in this all units will be covered in this steel structures and drawing. So these are the main important for the civil engineering to design steel structures, just like what you have reinforced design of concrete structures. So similarly we need to design the steel. So rather than RCC buildings, so steel structures will be preferred in high-rise structures, because it is easy to construct and a fast construction as a steel structures. So we are going to design those structural elements in this entire course. So this content of this course. So first of all, we need to cover the introduction on mechanical behavior of the steel. So in this, we are going to talk about materials and making of iron and steel, types of structural steels. So what are the mechanical properties of steel, different properties of the steel generally we will use while designing the structures, and a little bit concepts of plasticity and yield strength of steel. Especially we are going to use only steel, so we need to see the properties of the steel, just like yield strength and ultimate strength, all those things. So we are going to talk about the little bit concept of plasticity as well as yield strength. Then we are moving to loads and the combinations, different combinations of loads based on IS 875, different parts, part 1, part 2, part 3 and part 4, part 5 as well. So wind loads, then we are going to cover about wind loads and roof trusses. So this is entirely covers loads and combinations. Then we are going to talk about behavior of steel and what is the buckling concepts, different buckling concepts, especially while designing the compression members. So we need to know the local buckling failure, all those things. Then we are going to talk about concepts of limit state design. So especially this entire course is based on limit state design. So we need to know what is the limit state design and different limit states as per the IS 800 code and the strength limits, deflection limits, different deflection limits, the serviceability requirements for the limit state design. Then we are talking about the bolted connections, different types of bolted connections, as well as welded connections, different joints, what are the different types of joints, how to design those joints, what are the different types of bolts. So all those things we are going to cover in bolted connections. Similarly for welded connection, so different types of welds, how to design the welds. So everything will be covered here, welded joints and welded connections. And then we are going to talk about efficiency of the joint. It can be a bolted joint or a welded joint. Then prying action is basically for both the joints, welded joints as well as bolted joints, and different types of welded joints. Then we are talking about design of tension members. So basically these tension members and these tension members used in especially for the roof trusses. So we are going to design the tension members, how to calculate the tensile capacity of the members and how to design those members with the different criteria and design strength of the members. So this entire unit covers the introduction to mechanical behavior of the steel. Then we are moving to compression members. So in this compression members, we are going to design the compression members. Buckling class, what is the different buckling classes? There are 4 buckling classes: class A, class B, class C and class D. So we are talking about the different buckling classes. And then we are talking about slenderness ratio, how to calculate the slenderness ratio. For calculating slenderness ratio, we need effective length of the member. So how to calculate the effective length of the member, different end conditions. So based on that, we need to calculate the slenderness ratio. Then design strength, the strength of the member, how to design the compression members. So similarly what we have discussed tension members, so similarly we need to design the compression members. Strength design, how to design the members, the compression members. So especially in this design we are going to design by taking the beam members as a compression members, as well as built-up sections, how to design the built-up sections. So then we are talking about some laced columns, how to design the laced columns, how to design the base battened columns, and both combination of laced columns as well as battened columns. Then we are talking about column splices, how to design the splices, different splices, and column base. In the column base, we have two types of the column bases. So one is slab base, another one is gusset base. So in this we are talking about the only slab base in this. So then we are moving to beams, different types of beams, how to design those beams, what is the plastic moment capacity of the beams, what is the bending moments, how to calculate the bending moments. You might be known all those things. Shear force, how to calculate the maximum shear force and maximum bending moment. So based on those maximum bending moment and maximum shear force, we need to design the beam sections. So there are two types. One is laterally supported, laterally unsupported beams. And we need to design the built-up sections also in this. So by using larger plates for the built-up sections, and if you are using larger plates for the web sections, especially we are talking about web buckling, how we need to encounter the web buckling, how to design to web buckling and crippling and deflection of the beams, as well as design of purlins. Especially these purlins will come under roof trusses. So if you want to connect one truss to another truss, so we need to use the purlins. So those purlins we need to design as the beam sections. So we are talking about design of purlins in this beams also. Then we are moving to eccentric connections. So design of eccentric connections, especially these connections will be with brackets. It might be a bolted connection or it might be a welded connection. So both we are going to discuss in this eccentric connections, beam to beam connection, and beam to bracket connection, beam to beam, beam to column. So how to design the web angles and stiffened connection, unstiffened seated connections. So everything we are going to discuss in this eccentric connections. So design of truss joints, how to design the joints. If the members are meeting at a joint in the truss, how to design those joint with plates, gusset plates. So in this we are talking about all the connections, eccentric connections and all. So next we are moving for plate girders. How to design the plate girders and for the welded as well as both welded as well as bolted connection, bolted plate girders. So especially these plate girders are just like beams, but if you want to use the plate girders, means the beams are taking very heavy loads. So regular sections are not available in the market. So then we are moving to plate girders. So we need to use different plates, different sizes of plates for making the girder. It's a web plate, one thing, and flanges. So everything we need to use different plates. So in this, how to design and everything we are going to discuss in this plate girders. So first of all, optimum depth and design of main sections, how to design the main sections, and design of end bearings, hand stiffeners, bearing stiffness, intermediate stiffness, and what is the connection between web angle and flanges. So everything we are going to discuss in this plate girders. So these are the books generally we'll follow for this course. So first is reference books and textbooks. The first one is S.K. Duggal. We can use that, limited design of steel structures. And the second one is N. Subramanian, so design of steel structures. There are the four reference books generally we'll follow. We'll use the for this course, design of steel structures and drawing. So next we are entering into the course. So introduction on mechanical behavior of the steel. And so what is the behavior of the steel? So generally we need to know the behavior of the steel if you want to design steel members. So without knowing the behavior, we cannot design the steel structures. So in this we are going to cover all those things. So what are the advantages? What are the basic main advantages of the steel? Why we need to use the steel? So in this, the advantage of steel is the strength. The strength is very high for the steel, and erection speed of erection. So we can build a 10-story building within a month or so. So this is the speed of erection and prefabrication. So we can build all the member connections and everything in the shop, and we can transport it and we can build a structure. So demountability is very easy for the steel structures, especially if you want to remove one steel member, and we can connect at any time. So demountability is very easy. So easily recyclable. So if it is members are corroded, then we can easily remove those members and we can reconnect the members. So these are the main advantages. So but handled by trained persons. So these structures, to build these structures, so there are trained persons to handle these these structures. So these are schematic diagram of the steel making. This is not very important for the design, but still we need to know how the steel making process. Generally in steel factory. So generally they will take the limestone, iron ore and coal. So it will go to blast furnace. Then it will come to oxygen steel process. Then it's going to electric furnace, then scrap, and it is going to then pouring, then ingots. So ingots to again soaking pits and breakdown mill, bloom mill. Then it is going to create wide flange beams. So there are the iron and steel in India. There are the different plants in India. So Bokaro, especially Vizag is steel plant, Bhilai, Roorkela, Jamshedpur, and Bhadravati, Durgapur. So these are the main steel making industries in India. So they are the mechanical properties. These properties, especially we need to know for designing the steel structures. First one is ultimate strength. It is also called as tensile strength and yield strength of the material. So it is also called as proof stress. And the ductility, how to calculate the ductility, what is the weldability, the toughness. So so they are the mechanical properties: corrosion resistance, machinability. So this is a tensile strength stress strain curve for the steel. So if you see the red curve represents the high strength steels, the blue is represents the mild steel, structural steel. So generally we'll use the mild steel for the steel structures. Different zones, elastic zone, there are plastic zone and strain hardening zone. So this is based on IS 1608 curve. So we cannot use this curve for the for designing the steel structures. So we are going to idealize this curve by using this. So as per IS 800, so generally we will follow IS 800. So based on this IS 800, this is the idealized stress strain curve we will use for the steel structures. So they are the properties, different properties of steel material. As per IS 800, so modulus of elasticity, it is 2 into 10 power megapascals. Shear modulus is around 0.8 into 10 power 5 MPa, and Poisson's ratio is 0.3 and 0.5. 0.3 is for elastic range and 0.5 for plastic range. And unit mass, generally we know, everybody will know this unit mass of steel, 750 kg per meter cube. Quotient of thermal expansion is 12 into 10 power minus 6 per degree centigrade. Brenner hardness number, it is in between 150 to 190, and Vickers hardness number is 157 to 190. The approximate melting point is around 1530 degree centigrade. Thermal conductivity is 0.14 calories per centimeter square second per 1 degree centigrade per centimeter. So there are the mechanical properties. Generally, we'll use all these properties while designing the structure. So generally, we need to remember all these things while designing the steel structures. So in this lecture, we have seen different units covered, different. So the different different types of structural elements. There are the properties, material properties, steel properties, and how to make the steel making process. Everything we have covered in this lecture.
Like, share and subscribe. Hit the bell icon